Today we will start with the first lecture. In this lecture, we will discuss some basic understanding of internet and IoT. So, what is IoT? So, internet connect all people, which we call as Internet of People, and IoT connect all things like electronic devices, and we can call this as Internet of Things. Okay, so first point which we are discussing right here is the understanding of basic understanding of Internet of Things. So here we have the internet which connect all peoples, all people, and we can call it as what we call it as Internet of Things, or we can call it as Internet of People. The second point is IoT, which connects all things. What are those things? Those things are electronic devices, and what we called this as Internet of Internet of Things. So this interconnection of things, we have different electronic devices like sensors, actuators, mobile phone, electronic devices, home appliances, and all these devices are connected together through the internet. So that's why we call this as Internet of Things. Okay. So what is the basic structure of this internet? So the internet is not a single object. It is a global sprawl or device, or we can connect all the devices together using some cables that constantly request, transmit, and receive data. So let's draw the basic structure right here. Let's suppose that this is your computer, okay? And when you want to send some information, you have to connect your computer through the internet, okay? So let's suppose that this is your internet, and your computer is connected with this internet right here. Okay, and where you want to transmit your information, the receiver computer should also be connected with the same internet. Okay, so this is the receiver. Okay, and this receiver is also to be connected with the internet. Okay, so how this data moves through the internet, we have to discuss these things right here. So there are certain steps which we have to follow. Okay, so data is split into bits, or that bit is called some protocols, and each protocol which we are using travels through the internet via a series of checkpoints. Okay, so one possible journey of a packet we can discuss right here. Okay, so firstly we have this data right here. So this data which we want to see with the application. Let's draw this diagram. So first we have some application. Okay, so this application need to be sent using some data broken packets. So we divide this particular application into different packets first. Okay, so we have packet number one, two, three, and so on. So let's divide this whole application into different packets, and all these packets need to be transmitted to the media. Okay, for that we have to use some routers. Okay, for transport control protocols. Okay, so firstly this application is to be divided into broken packets. Okay, and then these packets which are broken, they are going to be transmitted to some transport control protocol, and through routers we can perform this particular operation. After performing this transport, we have to use some modems. Okay, so for that we have a particular transmission media. So that modem is used right here to transmit the signals. Okay, transmit the signals. So when these signals are transmitted, so those signals will be transferred to the local ISP. Okay, so this is your local ISP, internet service provider. So that internet service provider will transmit this signal to the local hub, or which we will use for the long communication, and we can call it as a long haul provider. Okay, so we will use this long haul provider. So this data is transmitted from here to border gateway protocol. Okay, so we use the border gateway protocol right here, and using this border gateway protocol, we transmit signal again to any additional network exchanges. Okay, so we have different exchanges. So we have to connect the da- data points with these different exchanges. Okay, and we can call them as network exchanges. So after transmitting the signal from these additional network exchanges, we have to send this data to long haul provider of destination. Okay, so let's suppose that you are transmitting your signal from India to USA. So here is a long haul service provider. Okay, so let's suppose that this is the world, and from here you want to transmit the signal. So we have to use a long haul provider for long haul provider of destination. Okay, so again the signal is to be transmit to the local service provider which are available at the final destination. Okay, so your signal will be received right here. So those signals to be transmitted locally right here. So this is again a local service provider, or we can use internet service provider as ISP. Again, we have to send this signal to the modem. Okay, and from the modem you have to send your signal to the router, and this signal is again transmitted to the packets. Okay, back to the destination, and here you will receive your signal. Okay, at your destination server, and after receiving, you can use some application to open that particular message which are transmitted from the sender to the receiver. Okay, so this is your sender, and this is your receiver. So these are the steps which we have to follow to get the data. Okay, so this application which you are transmitting from the sender, that is, these are the following steps which we have to follow to get the data at the receiver end. Okay, now let's concentrate the cables connecting to the world. So how your cables are connected through the world? So the internet relies on 5,15,000 plus miles of undersea cables to transfer information, and the world. Okay, all the continent, all the countries are connected together through wires, and these wires are interconnected with the uh, one point of a country to the another point of a country using cables. Okay, so this world internet exchange point, there are IEPs, and these IPEs are the network hub that guide this particular data packets to their interested destination. Okay, so let's suppose that there are different countries right here. This is uh, uh, this is Canada, this is USA, and let's suppose that this is Brazil. uh, we can use another country as Russia, and we will take our country as India. And so these countries are uh, present right here, and if you want to communicate with any one of these, so we have to connect uh, all the locations. Okay, we have to connect all the locations through some wires. Okay, so that each country can communicate with others. So we have to connect all physically through cables. Okay, the future of the internet structure is the tech giants are currently experiencing or experimenting with new ways of wirelessly improve the internet's accessibility and the speed. And there are some different projects which different countries are using. So Google is a big giant company. Okay, so they use the project Loom. Okay, so this project Loom is used by the Google. Okay, so this Google plan to launch a solar powered balloons into the stratosphere to provide internet to rural areas and help people connect their uh, uh, help peoples to connect. Okay, and there is a big giant company that is of Facebook. Okay, so this Facebook is having uh, Aquila drones project. Okay, so this Facebook plan to launch a fleet of solar powered drones into the stratosphere to provide the worldwide internet services. Then there is one another big company that is SpaceX. SpaceX satellite. So this SpaceX satellite IoT is that we are connecting the unconnected devices to achieve a purpose and should have some social outcomes. Okay, so to create any of the IoT device, we have to use some basic structures. So how we can use these basic structures? Firstly, we have to integrate some microcontroller. Uh, let's suppose that this is a microcontroller board, and this microcontroller board is getting information from the sensors, and we have to connect this controller with the cloud. Okay, to store the information on the internet, and we can access all the information uh, in our portable devices or whatever you are using. Okay, for the getting data. Let's suppose that you are using mobile phone, so you can get all the information over the internet on your mobile phone. You are using some laptops. Okay, so on that laptop you will get the complete data. So okay, so this is your laptop. Here you will get all the data. and you are moving anywhere. So let's suppose that you will get all your data while moving to one point to the another. Okay, so these are the applications where you can use this particular IoT device, and you can use uh, these devices also. You can use your own car when you are moving. Okay, uh, and you have some mobile phone with you, so you can access all the information through the sensors on your mobile phone while you are moving from one place to the another. Okay, so if you are moving, you constantly receive the data on your mobile phone. Okay, or you can also receive the data on your laptop or tablet. So who do you spend the most time with? Let's suppose that mobile phone we have most of the time on with our hand, or we can spend most of the time on the mobile phone. So we will get all the information right here. So that's is the big advantage to get this particular data. Okay, so mostly smartphone used all over the time by the peoples. 98% people use this particular mobile phone. Okay, and mostly 45% people uh, spend time when they are traveling. Okay? And current partners use mostly 65% of time with the conversation with your partner, and approximately 80% of the time we can spend if we have a laptop with us. Okay? So generally this internet of thing was proposed by the Kevin Austin, which is the founder of MIT Auto Identification Center in 1999. Okay, so who invented this Internet of Thing? Internet of Thing is proposed by the Gavin Gavin Austin, okay, in MIT, and in which year? 1999. Okay, so this IoT has officially presented by the International Telecommunication Unit. So initially, this particular Internet of Thing officially presented by ITU in 2005. So one of the major uh, disruptive technological development that can be considered in the next era in the IT sector, and this IoT helps to communicate between the people to people, and people to physical object, and physical object to the other physical objects. So this interconnections of IoT devices can create a new applications and services that can improve the human lives. And Internet of Thing is a state of the art where we can create architecture, communication technology, some protocols, and there are some different challenges also available to create these things. So we will discuss these things right here. So firstly, when you create the architecture, so this IoT world form will create the architecture commit released on the IoT interface module in 2014, and they have given their architecture, that how this particular uh, IoT system will look like. So firstly, physical devices you have, and those physical devices you need to connect with the system. So we the structure we will follow right here. Let's understand this. First level is your physical devices, and controller controllers. So what are the physical devices which we use in this IoT? So these physical devices like we use like sensor, then some devices, then some machines, and some intelligent edge node of all types. So we can use this nodes right here. The second here is the connectivity for creating the architecture of IoT. Okay, so here we use different communication and processing unit. Okay, so you have to use communication and processing unit right here. The third level is edge computing. So in edge computing, you have to use the data element analysis, and transformation. The fourth point is data acquisition, or we can use the data accumulation at this stage for the storage. Fifth, we will use the data observation, or we can also use this for the data abstraction. So we use the aggregation and access. Next point we will see right here for the application and the calibration and process. For the application, we reporting, analytics, and use some control over there. And lastly, we have to use the collaboration and the collaboration and process. So here we use to involve some people and we have to involve some processes. Okay, so we involve involving some peoples right here and business processes. So this is the basic architecture levels where you can create a IoT application using this particular architecture. After creating the architecture, we have to discuss how we can communicate with this IoT technologies. So there are different communication protocols right here, and we are going to discuss right here. So firstly, we have seen the Zigbee. So what is Zigbee? Zigbee is nothing but create a personal area network. So first is your Zigbee. First one is Zigbee. So what is this Zigbee? It create your uh, personal area network. So it will create your personal area network, such as you can create a mesh network, or you can create a star network, or you can also create a tree type of a network. Then second is your Bluetooth. So this is a very short range communication. Uh, Third communication technology we use as jet wave. Jet wave. So generally, this jet wave is a low power radio frequency, and that mainly built for home automation. Okay, so this is a low power radio frequency communication, and it is only used for the home automation. Next technology we have uh, is NFC. So just NFC is a very short range wireless communication protocol, especially for the smartphone, which connect let's payment transactions, and we can use this for the contactless contactless payment transaction. Okay. Fifth technology we are mostly using nowadays is Wi-Fi. So what is Wi-Fi? Wi-Fi is generally used for local area network. So we can use to create a LAN of devices, and we can access different uh, internets right here using this Wi-Fi technology, and we can create our own hotspot using this Wi-Fi. Okay. The next technology which we are going to see right here is the sixth one, which is 6 low W band. Generally, this technology is using IP version number 6, over low power wireless personal area network. So we are using this low power wireless personal area network. Okay, and this IP based standard, it can be connected directly to the other IP networks without intermediate entries such as transaction gateways or proxies. So generally, these protocols for transmission of this information for the IoT, we have to follow OSI and TCP IP model. So let's understand how this IoT protocol will work. Okay, so we have seen initially the OSI model, and for the internet we have seen TCP IP model. So this OSI contain the 7 layers. So how to remember this OSI layer structure? We have a simple formula right here. Please do not throw squeeze pizza away. So let's complete this. Please, first layer is P, to data layer, not network layer. Throw, transport layer. Squeeze, session layer. Pizza, presentation layer. Application is away. Okay, so this is your please do not throw squeeze pizza away. So you have to remember this OSI model like this. Okay, so physical data network transport session presentation, and lastly application. So these are the 7 layers right here, but in your TCP module we have only we have merged different application or with different layers right here. So in TCP we merge first 2 layers, and then we have the next layer as internet layer and transport layer, and we combine these layers of OSI model. So in TCP generally we have combined different OSI model layers, okay, to form a TCP IP model. So let's understand these right here. So this application, presentation, and session, all 3 layers combined together will make application layer in TCP IP. Whereas this transport layer is as it is. Okay, internet layer is there for the network, because we are using the internet line right here, so that's why this internet layer is there, and first 2 layers are combined together, so we will create this network access layer, and in this network access layer we are using different techniques to access the internet. So we are using the Ethernet, Wi-Fi, WiMAX, LR, wireless personal area network, 2G, 3G, LTE, and we can use the cellular data also. Whereas in this internet layer, we can use the internet protocol version number 4, internet protocol version number 6, and we can use the low power wireless personal area network also. So we can write it like this. For the transport layer, we are using transport control protocol and UDP module. For the application, we have HTTP, COAP, web sockets, MQTT, DDS, XMPP, and AMQP. So these are the protocols which application layer is using. After that, there are different challenges of the IoT. To handle these challenges, first challenge is the big data. So how we can handle this problem, big data. So IoT system involve billions of devices which generate a huge amount of data, and this IoT is one of the main source of big data. The second challenge for this is networking. And how you can solve this problem? So this IoT system has different devices which use a different communication networking protocol, and the smart networking protocols are expected to adopt the protocols already established in wireless sensor networks and machine to machine communication. So these different communication protocols and different network topologies create a significant challenge, and that need to be handled. Okay, so this big IoT data which we are using, we will use the IoT devices to generate a lot of data, and from many sources with a lot of diversity over time and all over the time. And this big data is a requirement for the massive storage, flexible access, and paradigm analysis, pattern recognition, decision automations also. And then we have the heterogeneity. Okay. Next challenge is your heterogeneity. So this heterogeneity is available in IoT, and this IoT system uses a wide variety of devices with different features which make the connectivity and coordination process very difficult. So this heterogeneity is also a big challenge for the IoT. Then next is the security and privacy. So this is the next challenge in IoT. So this IoT is vulnerable to most of the wireless common attacks because of most IoT devices are connected through wireless network and that are hard to protect against different attacks such as man in the middle attack and other attacks. The next big challenge is the maintenance. So how this maintenance problem is available in this IoT. So this maintenance is a serious challenge to recognize a billions of new devices, flood of internet, and upgrading their devices to the latest platform and the fixed security. So thank you very much for attending this particular session. I am uh, going to create a complete series for this particular